Welcome. In this video, we're diving into a brand new AWS security feature, VPC Encryption Enforcement. This capability allows you to enforce that only encrypted, TLS-protected traffic is permitted within your VPC. Any unencrypted traffic is automatically blocked unless you choose to exclude specific resources. It's a major step forward in bringing zero-trust principles directly into your VPC network. To help you understand enabling this feature, we'll walk through 4 practical demos. Enable encryption enforcement on a new clean VPC. Check which resources block encryption enforcement. Enable encryption enforcement on an existing VPC with no blocking resources. Show why some existing VPCs may not allow enabling enforcement. Let's get straight into the hands-on work. We'll start by enabling encryption enforcement on a brand new clean VPC. For a new VPC, we can enable encryption enforcement using either the AWS CLI or the AWS console. I'll show you both, but we'll begin with the console workflow. Before touching the command line, let's create a fresh VPC and enable encryption enforcement directly from the AWS console. From the VPC console, select Create VPC. I'll name this one New Clean VPC and then allocate a CIDR block. Right here during creation, you'll notice the new VPC encryption control feature. And like with any new AWS capability, we always need to understand the cost impact. When we check the VPC pricing page, we now see a new tab called VPC Encryption Controls. As of now, the feature is free until March 1st, 2026. After that date, the regional pricing displayed here will apply. When creating a VPC, we have 2 modes available for encryption control: Monitor mode, Enforce mode. We'll proceed with Enforce mode for this clean VPC. After selecting our encryption mode, we proceed with creating the VPC. Once the VPC is created, you'll notice that it now shows a non-empty encryption control ID, confirming that encryption enforcement has been applied. Next, let's move over to an existing EC2 instance so we can use the command line to work with the VPC encryption APIs. Before you can enable encryption enforcement on any VPC, AWS requires you to run a compliance check. This scan inspects the VPC and identifies any resources that would break traffic flows if enforcement were turned on. Here is the command used to initiate that compliance scan. However, during testing, I discovered something interesting. Although the documentation already shows the AWS CLI commands, they don't appear to be available in the CLI yet. This may be due to an AWS CLI version issue, or simply because the commands haven't shipped to the public CLI at the time of recording. As you can see, running the command directly in the CLI results in an error. To work around this, I'm using Python Boto3 to call the underlying API directly. The API calls themselves are valid, so the Python approach works even when the CLI commands don't. Let's look at the same CLI operations implemented inside the Python script. We'll start with the script that performs the compliance check for any resources that could block VPC traffic flows. I'm showing the script in visual here for better visibility. The same script is already preloaded on my EC2 instance. I only need to update the VPC ID parameter. After running the script, we see the internet gateway listed as a non-compliant resource, meaning enforcement can't be enabled unless the IGW is removed or excluded. Back in the VPC console, select our default VPC. There's no encryption control ID because enforcement isn't enabled by default. Under Actions, Edit VPC Settings, there's still no option to enable encryption enforcement. This confirms that enforcement on an existing VPC can only be enabled through the command line or other non-console methods, such as the SDK. In my case, I'll use Python with Boto3 since the AWS CLI didn't work. From my Visio tab, here is the simple VPC encryption enforcement script. The same script is already on my EC2 instance. As with the scanning script, I simply update the VPC ID to match the target VPC. After running the Python script, we see that encryption enforcement is applied successfully. But note that the mode is monitor, not enforce. Back in the VPC console, we can now see that our default VPC has an encryption control ID and the control mode is set to monitor. Selecting the control ID shows the list of supported exclusions. Let's now attempt to switch the mode to enforce. We immediately see that we can't proceed unless we add an exclusion for the internet gateway, the same blocking resource identified in the initial scan. Since this process can take some time, I'll switch over to another existing VPC that was created without any blocking resources so we can continue with our demos. As noted earlier with our default VPC, the console offers no option to edit or enable VPC encryption on an existing VPC, which is exactly what we see here. Let's switch over to our Python script. Update the VPC ID and, just to confirm, try the AWS CLI one more time, but it still doesn't work. Now run the Python script and we get a successful result with monitor mode applied. Back in the VPC console, switch the mode to enforce. This time, enforcement succeeds with no blocking resource errors. Now that we've seen how to configure it, here are some real-world use cases. Compliance-driven environments, industries that mandate encryption in transit, such as finance, healthcare, and the public sector, can enforce encryption across all VPC traffic. Multi-team or multi-account environments. When multiple teams or accounts share a VPC, enforcement ensures no workload bypasses encryption requirements. Zero trust and defense in-depth architectures. Encryption enforcement helps prevent any accidental or intentional use of unencrypted network path inside AWS. Security baselines for production VPCs. Organizations can standardize new workloads by enforcing encryption as part of their core security posture. Thank you for watching and happy, secure cloud computing.